This is an actual example at CNS, Centralized Storage. It's in New York. You have a user in San Diego. Okay, the distance between San Diego and New York is fairly great, and in this case, that accounted for 86 milliseconds of round trip time. Now you might think, hey, 86 milliseconds, not that big a deal if I do it once, and you would be right. But what you'll see is it happened a whole lot more than once. So like most customers, they upgraded their bandwidth, they added some WAN acceleration, they made that bandwidth hotter. And I don't know if you can see that transition, but the lines got red. But what you don't see is those lines didn't shrink. The round trip time is still 86 milliseconds. So let me show you how that gets affected. What we noticed when we looked at this project, again, very, very small project, is in order to open this template file, there was many, many checks. In fact, in this case, the file opens and locks that the application was doing to verify that template and all of its dependencies happened to account for over 4,500 round trips across that network, across that latency. Okay, and in this case, if you do some very, very simple math and you multiply 4,500 times 86 milliseconds, you're up at approximately 6.5 minutes. Okay, now let's think about it. If you're going to do opens and locks, you're going to do approximately the same amount of closes and unlocks. And prior to that, you had to do about the same number of lookups. So if you add all those up, you're up around 18 to 20 minutes. And you haven't moved any data, you've just checked. This is the chatter, if you will, of opening a project. It's all the verifications. And these are things that bandwidth and WAN acceleration cannot address. You cannot cache the fact that somebody deleted a file, or that somebody added a file, or somebody changed the file. You can cache the file, but not the fact that it did change. Okay, so at the end of the day, hey, yeah, I've finished all those checks and now I actually need to move the 1.5 megabytes. Great, that's 1,000 packets. It's really no big deal. If you do the math on that, that's 7% of the network traffic was actual data. The 93% in this case was chatter. Okay, and if you do some simple math and add that all up, that comes up to 22 minutes. And that's exactly what the end user was seeing, waiting for that simple template to open in San Diego as they were pulling it in from their New York headquarters. Very, very painful. So let's look at the same situation with Panzura. Same project, centralized storage, but in this case we've got a Panzura device, one of our little servers, and this is typically a 1U or a 2U box. And when I say a U, that stands for rack unit. Oftentimes a 1U is considered a pizza box. That's approximately the shape of it. And in this case, because it's deployed locally, you now get local latency, down the hall type latency. And in this case, it's half of a millisecond. Notice it starts with a 0 this time. It's approximately 150 times faster. Okay, so we didn't change anything. In this case, this is a Cvil 3D example. In this case, Cvil is going to do the exact same thing. The 4,500 opens and locks, approximately the same number of closes, lookups, and unlocks. Okay, and if you're doing some math here, 15,000 times half of a millisecond is very, very short. We're at 6 or 7 seconds at this point in time. And finally, moving the data, hey, we're going to do all the right things on moving that data as well. It's going to be compressed. It's going to be deduplicated, and we'll talk a little bit about that in a second too. We're going to use that network efficiently. When Megan was introducing us, the legacy of our company is a collection of very, very strong and seasoned network engineers. We're leveraging that history as well here to move this data. Now, if you're doing the math here and adding this all up, this is 8 seconds. We just changed 22 minutes into 8 seconds. We'll tell you exactly how we do it in addition to just deploying a device there. But beyond this, you get some benefits, right? Because you can't just create data, you've got to protect the data. Typically, you're backing it up, you're doing some other things. You have some tapes, or you have a person out there that on a nightly basis kicks off a process. Hey, we're doing that automatically. As those changes are coming in, not at the end of the night, not at the end of the week. As the changes are coming in, we're sending them to that centralized location to make sure they get protected there. Again, we're also optimizing the bandwidth. I already talked about that a bit. But the final benefit, and there is just one more thing here, is I have the ability to not just do that at one site, I have the ability to do that at N sites all at the same time. And in this case, I've shown 5 sites here. Remember, our biggest example so far that I've given is the U.S. Department of Justice. Over 260 sites, right? And so the benefit is this is where we have what we call a global file system. Okay, I don't just present files and folders at one location. I have the ability to present those same files, those same folders, those same permissions, the same consistent locks at as many locations as you want. And every location can get that same level of performance. In this case, the 8 seconds.